Welcome back to the deep dive. It's so easy to think of ancient history as, well, primitive.
It is, yeah. But that's just not the whole story.
Not at all. Today we're unpacking sources on water management, and it really shows that this wasn't just about survival. It was. It was the foundational technology for these massive civilizations. Rome, the Maya, the Indus Valley.
It's the ultimate key to societal stability. We're going to look at how these empires handled water, focusing on three main things:
Okay.
the sheer technical evolution, the huge challenges they solved, and of course the societal impact, the way it changed everything.
Let's start with the how, then.
Yeah.
And you have to start with the Roman aqueducts.
Yeah.
We know they built 11 huge systems over 500 years. But the precision, that's what always gets me.
Precisely. They weren't using pumps, it was all gravity, which meant they needed an absolute mastery of slope.
Right.
The sources show they kept it in this incredibly tight range, a drop of about half a meter to 1 meter for every kilometer.
Wow. That's less than 1/10 of 1%. It sounds almost flat. Why? Why so subtle? Wouldn't a steeper drop just guarantee faster flow?
You'd think so, wouldn't you? It seems counterintuitive, but that's the genius of it.
Okay.
If it's too steep, the water flows so fast it would literally tear apart the concrete channels.
Simple physics.
Exactly. But if it's too gentle, sediment builds up and clogs the entire system. They found that perfect velocity, about half a meter per second, to keep it moving without causing, catastrophic erosion. It was fluid dynamics perfected.
So if Rome was all about this monumental engineering, the Maya were masters of a kind of stealth high-tech.
Oh, absolutely.
They were solving for clean drinking water in a way Rome never did, with filtration systems going back to 235 BC.
This is where we see some truly hidden technology. At sites like Tikal, they had this amazing dual system using crystalline quartz and zeolite.
Zeolite, that's a silicon and aluminum compound, right?
That's the one. It essentially acts as a natural molecular sieve. They were actively filtering out harmful microbes, heavy metals, using principles we recognize from modern chemistry.
And this was 2,000 years before Europe even got close to that.
2,000 years. It's incredible.
And that idea, that shift from massive public works to subtle, high-impact tech, that brings us right to the challenges they solved: urbanization.
Exactly. Rome could not have supported its massive population without those aqueducts. Simple as that. You just can't grow beyond the limits of your local wells.
The infrastructure was the prerequisite for Rome becoming the million-person city it was.
And managing it all required governance. This wasn't just a free-for-all. It was a highly managed, prioritized resource.
How so?
Well, the system prioritized the public good first. So public fountains, the fontes, and then the public baths, the thermae.
So everyone got the basics.
Everyone got the basics. If you were wealthy, you could pay a fee for a private connection, an aqueductus privatus. And get this: the lead pipes were often stamped with Imp Caesar Aug,
Imperator Caesar Augustus.
the emperor's name, right on your plumbing.
So that's not just a brand name, that's proof of payment.
Yeah.
And it's also a kind of quality control, right? A guarantee from the highest possible authority.
You've got it. It's proof that infrastructure creates the earliest forms of sort of a regulatory state. And if we look at the biggest societal impact, it has to be public health.
Fewer waterborne diseases.
Dramatically fewer. But for integrated public health, we have to look to the Indus Valley civilization. They took it a step further.
They weren't just thinking about bringing water in.
They were thinking about taking it out. They built the world's first known urban sanitation system, house-by-house wells, dedicated drainage channels, a holistic approach. It was revolutionary.
So when you pull it all together, Roman hydraulics, Maya filtration, Indus sanitation, this is clearly the groundwork for modern civil engineering. But what's the big takeaway for us today?
I think it's the philosophy. Look at the Dujiangyan system in China, built around 251 BC. They used a no-dam principle.
No dam. How do you manage a river with no dam?
Their focus was on following the current and adapting to the season. They managed the flow without radically disrupting the river's ecosystem.
So harmony with nature rather than domination over it.
Precisely. And that raises a really important question for all of us today, as we face climate change and growing cities. Are these low-impact adaptive philosophies a better guide for our future than just building the next big, high-tech, high-impact solution? It's something to think about next time you turn on your tap.